Greetings, EHS 300. This video is being made for the writing intensive lab portion of the course. So the next lab report we've got, which will be the last original lab report that you have to produce for the class, it's focused on the fecal indicator bacteria lab and the determination of whether or not Lake Reba's water would meet recreational water quality criteria, primary and secondary criteria. So that's the focus of this video, and we're going to go over the helpful information that's in there in Blackboard for you to be able to accomplish this task. And then lastly, I just want to add that I'll email the different groups what the expectations are going to be, because a lot of the groups may need this to happen individually because there might be challenges working together remotely. And I think for achieving the objective of this class, this is the only writing intensive class that you're required to take for your degree. And I created this class 8 years ago just so that you all would be able to take a writing intensive class in your major rather than having to take something in addition to your gen eds. So it's important that I do this in a way that the university feels comfortable that we're meeting the writing intensive requirements of the class. So I'm going to provide very specific instructions in this video on how to accomplish this task, and then I will work through email with the various folks in the class on making sure that we're able to get lab reports submitted by April the 30th at 11:59 p.m. So that's late on a Thursday night. That'll give me the chance on a Friday to review everything and turn it back, and if there's any need for revisions, be an opportunity to enhance your laboratory grade and your overall grade for the class. All right. So moving forward, the actual report, I've provided a template for you to use. You can download that template from Blackboard. There's a document that should be loading up on my computer right now. Here we go. Here's the template. I'll zoom in. You'll want to provide a title that may say something about, fecal indicator bacteria assessment at Lake Reba, or something to that effect. You'll want to put your name, or if it's a team project, the names of the individuals in the group. Here's the due date, 30th of April. This should all stay the same. For your actual abstract, what you'll need to include is this kind of information. It's important to write the abstract last. You don't want to write it first. The abstract should be a summary of your entire paper. The abstract should probably be no longer than 200 to 300 words in length. You can see the amount of space that's here. If I were to check on the word count, it says that's 265 words, so it should be about, this length. It can be less than that, or it can be a little longer than that. Your abstract should include why the paper is being done. It should include a brief summary of the methods that were used. It should include the major results and findings, and it should include a concluding statement or conclusions set of statements. All right, your introduction. Your introduction should explain why this report's being done. Write this report as if state or county officials asked you to evaluate whether Lake Reba is safe for swimmers one day and safe for current, like fishermen, water anglers, and kayakers and boaters. So swimmers aren't allowed to swim there currently, but one day maybe the county wants to allow that. So this is primary contact recreation. This is secondary contact recreation. Is Lake Reba safe? Ideally, you'll also incorporate some references from peer-reviewed journals or government standards. Not just ideally, if you want optimal points based on the rubric, you'll want to do that. You'll also want to use a consistent formatting style, I give you some descriptions here of how to do that. To look at our rubric, which I'll pull up and zoom in, to achieve optimal points in the introduction section, at least 5 reputable background sources should be used and cited correctly and translated into your own words. We paraphrase in the sciences. References cited should be done in a consistent manner common for the sciences. Do not use websites. If you're going to cite anything, you should be citing peer-reviewed documents or US EPA documents or Commonwealth of Kentucky documents and laws or regulations, not websites. I don't want to see any websites. All right. Next, after the introduction section, for some extra hints in the introduction section, you'll want to explain why we examine recreational water exposure, how human illness risk may be determined. I give you several documents that you can read over that will help. The relationship between recreation illness and E. coli is described in several papers that are provided on Blackboard. A mention of why we're doing this would be important, like why this type of analysis is important. You would want to mention that you're trying to determine if the water is meets standards for primary and secondary contact recreation. All right. You can also mention potential pollution sources that may contribute fecal matter to Lake Reba or similar lakes. You ought to consider citing the standards here for Kentucky and US EPA, saying that you plan to compare the results to the recreational water quality standards set forth by the US EPA and the Commonwealth of Kentucky. And then you can cite where those standards are located. And I'll provide you those examples here in a second. Methods. For the methods section, you need to be able to go through and explain that the samples were collected in one day in March 2020 using sterile Nalgene bottles. They were collected from the boat dock at Lake Reba. They were transported on ice in a bucket to the lab. They were analyzed within 6 hours of collection. They were used for assessing the density or the amount of total coliforms of E. coli in the water. The IDEX ColAlert method was used in a 10% and 100% format. They were incubated using the IDEX ColAlert method at 35 degrees Celsius for 24 hours. They were enumerated using the the EPA method 1603 with Hawk brand MTech agar. You all did filtrations of 50 milliliters and 100 milliliters. Those were incubated for 2 hours and then incubated further for 22 hours at 45 or 44.5 degrees C. So 2 hours for resuscitation, 22 hours at the higher temperature. The IDEX plates and these E. coli plates were transformed if they were in like a 50 mil volume to 100 to CFUs per 100 mils. And the 10% sample, they were converted to what? To MPN per 100 milliliters. All right. After describing these, you can then say that the results are then to be used to compare with primary and secondary contact recreation standards. Results and discussion. All right. If you choose to combine them, that's okay. If you choose to separate results and discussion, just know that when you make that decision, if you separate results and discussion, the results section should only describe the results. There should be no interpretation of those results. But if you combine them, you can blend your results summary with your actual discussion of what the results mean. All right, tables are labeled above. I provide all the data for you. I already made the table for you. You just need to give this table a caption. This table here is based on the IDEX data. The 10% samples have already been converted to MPN per 100 mils. The 100% samples, they stayed in MPN per 100 mils. These are the total coliform data. These are the E. coli data. These are the ones that we care about the most because they're the ones that are most linked to health. These are the ones that the standards are based upon. These have very little utility, so you don't need to spend much time writing about total coliforms. Most of your writing should focus on E. coli. Again, these are from the IDEX method. These results are from the colony forming units, modified MTEC, membrane filtration method. These 50 mil filtrations have been converted to E. coli and CFUs, or colony forming units per 100 mils. These 100 mil filtration volumes were already providing CFUs per 100 mils. All right, you should be able to compare the IDEX values, 31, 29, and 24, 31 and 29 from IDEX and 24 from the membrane filtration, with each other as it relates to the results. They look pretty similar to me, and I think that that's okay. If you really wanted to do t-test analysis or something like that, more power to you, but it's not required. But overall, pretty similar. The 50 mil volume gave us 40. The E. coli 100 mil volume gave us 24. These gave us 31 and 29. So if you were to average those, you're looking at about 30 E. coli. If you were to average these, 64 divided by 2, about 33 E. coli. Pretty similar in the big picture. If you want to make this in italics, like I did above, you can do that. All right, so that's kind of the results. If you combine results and discussion, you can include all this in the same section. If you separate the discussion content out, so be it. That's fine too. This is the part where you need more references, probably another 4 or 5. Tell us what the results mean. Discuss your results. Do the E. coli data from these methods suggest whether or not Lake Reba meets or does not meet recreational water quality criteria? Specifically, does it meet primary and secondary criteria? Tell us that Lake Reba is not designated for swimming currently by the community, but if it were to be considered for swimming, how do these results compare? Looks like they meet standards to me, so how do they compare? What are those values? Cite those values. Beach action values are the values that are in the actual EPA criteria. We meet those. For freshwater E. coli, here's the standard. All right. If you're curious what the standard's based on, it's based upon these studies called the NEAR study, and we're trying to make standards for the country that didn't make people sick, that people could swim in and there'd be a low risk of gastrointestinal illness. All right, the EPA also has monthly standards to determine if the water is impaired or not for the 303D list. So are there days that it's bad occasionally, or is it consistently bad? You don't have the ability in this paper to evaluate whether or not it's impaired for contact recreation over the entire month. But you can look at it and see what those numbers would be and tell us, are we on track to meet that standard? How do your samples compare against the geometric mean of 126? And are 90% of the samples, or whatever samples we had, below 410 E. coli based on the single day assessment? So there's a single day beach action or swimming advisory level, and then there's a month-long average. It has to meet that to go swimming, or to have no advisory sign put up. It has to meet these to be able to meet the monthly standard. How do you compare? Looks like it meets both of them to me. All right, the Commonwealth of Kentucky also has a primary recreation standard of 200 CFUs per 100 mils. We didn't do secondary contact recreation using total coliform. We measured total coliforms. The state of Kentucky's got a law that says that secondary contact recreation can be assessed using fecal coliforms. Well, if our total coliform values are meeting it, then you know that the fecal coliform values would also be meeting it. So you can indicate that if you were to have measured fecal coliforms, you would have met the secondary criteria, assuming it meets it. Lake Reba is designated as a secondary lake. All right, that's a current use. People who swim there and fish there, we'd like to know, is it safe? Or does it meet the standard? That's the better way of saying it. You don't want to say it's safe. You want to say it meets the standard or doesn't meet the standard. All right. There are still E. coli in the water. Where might the E. coli have come from? You should tell us. And you shouldn't just tell us based on speculation. What are some possible reasons for these E. coli to be there? How could rain bring this in? What about geese? Some of them things are poop machines. Use the references provided. There are articles on Blackboard about stormwater when it rains, transporting fecal bacteria into the water. What about E. coli being in the sediments and the water washing back and forth then by wave action? What about birds defecating on the shoreline? What about algae in the lake, potentially providing refuge for the E. coli to live longer? Those things are things that you could put in there. Discuss the important findings and limitations. This is very important. Discuss the findings and limitations. Is 1 day of sampling enough? Does 1 day of sampling in March actually tell us a whole lot about swimming in May, or probably actually more like June, July, and August? You would need to mention that regular assessments during the recreational season would need to be performed. If you're going to be doing this kind of work as a consultant, encouraging more sampling is always a good thing. And if things ever go awry, you can always say, well, we said that more sampling would be needed, so that covers yourself. For a lab report in a junior EHS course, you would need 4 or 5 new references in the discussion section. So again, let's pull up our rubric. I'm going to go down to discussion. Typically 3 to 4 new citations, kind of the minimum I'm recommending here for this class. So you should have in total probably about 9 peer-reviewed references and or government reports cited in your document. I'm not making you research them. I provide them for you. All right. The conclusions. They should be a brief recap. You can do these in bullet fashion. All right. So I provide other resources. I provide another document. Let's see. I'll pull it up here. Fecal indicator, step by step. This gives you references that you can click on and choose from. E. coli utility as a fecal indicator. All right, there's a paper you could use. What else do we got? Beach water and illness. What about the value of fecal indicator bacteria for preventing people from getting sick from swimming in recreational water? All right, what else do we have? Standards. EPA standards. So there they are. I think I tell you to go to like page 50 for the beach action values. All right, so this is beach action values. Page 44 of the document, page 50 of the PDF. Here they are. You should be able to cite the US EPA for this particular document. Kentucky Administrative Regulations. I think on Blackboard I actually provide you, in case that website doesn't work, course documents, Lab Folder 2, supporting PDF files, reports, and more, state and federal standards. You can click on that and get the web link. Here you can download it. There's the law, 401 KR 10031. You can read this law. It's got a lot in it. It's all the surface water standards. But you can search, Control F, recreation. Section 7, recreational waters. And zoom in. Keep zooming in. You can read this on your own. Alright. E. coli content shall not exceed 200 colonies. Over the given month, 130 per 100 mils. It should be kept below that. Alright, there's more. There's something else somewhere about secondary contact recreation. Control F, secondary. Maybe I was already there, I just messed it. It's hard to see when I zoomed in so much. Under section 7. I know it's in here. Here we go. Fecal coliforms should not exceed 1,000 per 100 mils over a 30-day mean, and not less than 5 can exceed that many. It can't exceed 2,000. So those are the secondary standards. Are we on track to meet them? You've got the data to make an informed opinion on that. You measured total coliforms, and if total coliforms aren't 1,000, then you know fecal coliforms definitely aren't 1,000, because total coliforms includes all the fecal coliforms and even some more bacteria. So you've got all the information you need. You've got the rubric and everything along with it. So what I encourage you to do is just follow that rubric, look at it, do the template, use the template. The table's already made for you, and take it one step at a time. You don't have to use all the references provided, but you have enough. If you only need to use 9 to get your full grade, and 2 of them are EPA, US EPA's standards, and another one is Kentucky standards, it leaves you with 7 peer-reviewed references that you should be using. So if you have questions or difficulty trying to understand how to upload things or cite things, you can email me, and I'm happy to discuss or work with you on it. So I'm going to stop the video here. All the references and resources you need, though, are there. So you shouldn't have to do external research. You've got the information to base the report on already provided. All right? So I'll stop the video here and email me if you have questions.